I am SUKESH. I am going to explain you about the data structure mini project. Now let me explain the problem statement. A flight route planner that determines the most efficient route for flights between different airports using graph in this project is really helpful. The airports could be represented as node and the flight between them could be represented as edge. Let me explain the objective. Here we are going to determine the flight route that is most efficient, and we use the DIJKSTRA algorithm to find the shortest path between the airports. Let me explain about the project description. Here we have the nodes that represents the airport and edges that represent the direct flight between airports weighted by the flight distance. Our goal is to find the shortest possible flight route between two airports. So we are going to use DIJKSTRA algorithm, which will be said later. And we have the key features like graph representation, DIJKSTRA algorithm, efficient path finding, and input output. Like First, let me explain you about the graph representation. Airports will be like a node which represents which is usually represented in a graph, and we have the edges in graph. So here the edges will be like the distance or the connecting airports between the two flight, and we are going to use DIJKSTRA algorithm since it is usually used to find the shortest route, and the result is the shortest travel distance and the path of an airport taken. And here we use the efficient path finding, which again relies on DIJKSTRA algorithm, and we have the input output. When the user gives the input like adjacency matrix, the system outputs the shortest distance between the two selected airports along the exact route taken. Let us first understand this with the real-time example. We have here Delhi, Bombay, Bangalore, Hyderabad, the four major airports in India, and we have Chennai too, but it's not the major airport. Let me explain first with the four airports. This is just for an example. And here we have the graph representation. As we said, the graphs are the airports. Here we have Delhi, Bombay, Hyderabad and Bangalore airports. And the distance, as we said, is the edges between the airports. Here we have Delhi to Bombay 1150 km, Delhi to Hyderabad 1265 km, Bombay to Bangalore 835 km, and so on. Here is the representation of adjacency matrix between airports in kilometers. Here we have 0 since Delhi to Delhi is the same place, so there is no distance. Likewise Bombay and Hyderabad and Bangalore. Let's take this as source distance, this left column, and here we have the top row which represents the destination airports. We have Delhi to Bombay 1150 kilometers as given in the problem state as in the graph representation itself, and we have Bombay to Delhi as well, because Delhi to Bombay and Bombay to Delhi are same distance, so we have 2 times the same distance. And let us apply the DIJKSTRA algorithm. Let me explain you about that. Let's take the source as Delhi and destination as Bangalore, and here are the steps to find the shortest between Delhi to Bangalore. Let's compare the direct flights and connecting flights through Bombay and Hyderabad. here we have three routes, possible routes. First, let's go from Delhi to Bombay and Bombay to Bangalore, which costs about 1985 kilometers. And here we have Delhi to Hyderabad, then Hyderabad to Bangalore, which total cost distance is 1835 kilometers. And we have the direct flight to Delhi to Bangalore, that is about 1740 kilometers. By seeing this, by comparing this, we can say that Delhi to Bangalore direct flight has the least kilometers possible distance. But let's find an algorithm, let's write an algorithm to solve the problem without even knowing how much distance, manually calculating the distance. We use the algorithm like DIJKSTRA, and we can also use our own algorithms as well, but DIJKSTRA is the most efficient algorithm as of now. So let me explain you about that. First, let me explain you about program. Here we have the header files and we define the vertices 4, since we have 4 airports defined. And here the minimum distance function finds the airport with the smallest distance that has not been processed yet. And here we have the DIJKSTRA algorithm, like let me show here. We have DIJKSTRA algorithm code here, which will be like we apply it to find the shortest path from source airport to the destination, updating the distance and path while we iterate through the loops here. Like here we set the initial values and we update the source distance as 0, since we saw here the source and the destination distance between two airports is 0 if the two airports are same. So we included here the distance of source is equal to 0, and we have the loop that runs to find the distances with the minimum distance code that we already written. And we have here the function to print the solution, which is then called here in main function. Now here in main function we have the graph, which we saw here like in tabular form. We represent it in code like this, and here we have the source destination variables which is inputted by the user, and we call the DIJKSTRA function with the graph, this graph, and we pass the parameter source and destination, and the DIJKSTRA algorithm will do the shortest path finding and gives the result by calling the print solution function, which then prints the shortest distance from airport. Here we took the Delhi to Bangalore example, so it will be like shortest distance from airport Delhi to airport Bangalore is 1740 kilometers will be our output. Let me show the output here. Here we have the available airports: Delhi, Mumbai, Hyderabad, Bangalore. Here it asks for user to enter the source airport from 0 to 3. Since the position in the array starts from 0 to 3, most of the programming languages follows the 0 indexing, so it takes like that. And after passing Delhi and Bangalore as an input, we get the output as shortest distance from airport 0, that is from Delhi to Bangalore is 1740 kilometers, and the path is direct from 0 to 3, as we have seen in the algorithm here. Delhi to Bangalore direct flight is 1740 kilometers. That's it about the project, and I hope this sounds good. Thank you.